Python supplies a couple other operators as well. The first is a little bit strange. It's called floor division. Floor division mimics the way integer division works in many other languages. It effectively divides two integers, and then it rounds the result down to the nearest integer. It's represented by a double slash. So note how this code works. On lines 1 and 2, we create our variables 3 and 9 again, and we give them the values 3 and 9 just to make our code pretty easy to read. Line 3 is blank, so it's skipped. Line 4 is a comment, so it's skipped. And so when it runs line 5, we see the same result we saw earlier. 9 divided by 3 is 3, but Python adds the point 0 because it doesn't have any way of guaranteeing that the result will be an integer. So it goes ahead and assumes that the result will have a decimal. On line 8, though, it uses that floor division operator instead of the regular division, and the result is what we might have expected originally, 3 without a decimal. So using floor division gives us the integer 3, while using regular division gives us 3.0. Numerically, we understand that they're the same value, but one is prepared for different kind of operations than the other. As we saw before, for example, we can actually multiply a string by an integer to make multiple copies of that string, but we can't multiply a string by a floating point number or a decimal number. When we use the floor division operator with numbers that are not evenly divisible by each other, we see this difference more clearly. The division operator includes the decimal, while the floor division operator rounds down. So here we create 3 new variables, 2, 5, and -5, and give them the values that make sense. And then when the computer runs line 6, it divides 5 by 2, finds the answer is 2.5, and puts the answer up here. When the computer uses the floor division operator on line 9, it again divides 5 by 2, but it rounds the answer down. So 5 divided by 2 with the regular division operator is 2.5, but 5 divided by 2 with the floor division operator is 2. What that means is that the floor division operator really asks a different question. It doesn't ask how many times does one number go into another, it asks how many complete times does one number go into the other. 2 goes into 5 2.5 times, which means 2 goes into 5 2 complete times, and then there's some left over, the 0.5. Note also how this interacts with negative numbers. When we use regular division on negative numbers, the result doesn't really change from what we'd expect. -5 divided by 2 is still -2.5. When we use floor division, though, note that it rounds down, not towards 0. So -5 divided by 2 using floor division is -3. That's because -2.5 rounded down rounds down to -3. It might seem like it should round towards 0, but it always rounds down to the next lowest number. To be honest though, I can't say I've ever found a reason to use floor division or modulus with negative numbers, so you'll probably never see that. There's one other somewhat unique mathematical operator that Python supplies. It's the exponentiation operator. Most languages that I've seen use a function to supply this capability, but Python reserves the double asterisk for exponentiation, as we see here. Again, we create our variables, and line 6 prints the result of 5 raised to the 2. The first number is our base, and the second number is our exponent. 5 to the 2 is 25. If we reverse those numbers as we do on line 8, we instead get 2 to the 5, which is 32. Exponentiation works with negative numbers as well. If we square -5, our result is still 25, because squaring a negative makes it positive, or a negative times a negative is a positive. We can also use negative exponents like we see on line 12. 2 to the -5 equals 0.03125, which is the equivalent of 1 over 32, or 1 over 2 to the 5th.